Hello everyone. So today we have 2 to the power of m plus 4 to the power of m plus 8 to the power of m equals to 39. Let's solve together by saying solution. So recall that 4 can be written as 2 to the power of 2 for this, and 8 can be written as 2 to the power of 3. So if we replace this, our equation will become 2 to the power of m plus 2 to the power of 2 to the power of m, which is 4, plus 2 to the power of 3 to the power of m, that is for 8, is equal to 39. And we're very fine. We're going to remember the fact that when a is raised to power m raised to power n is same thing as a raised to power n times m. Here, our equation will become 2 to the power of m plus 2 to the power of m also raised to power 2 plus 2 to the power of m also raised to the power of 3 is equal to 39. Here we have 2 to the power of m, 2 to the power of m, 2 to the power of m. We can say let 2 to the power of m be represented with x, so that our equation will become x plus x to the power of 2 plus x to the power of 3 for here equals to 39. The next thing we will do, we're going to split 39 into 3 numbers, and we're going to write those 3 numbers in an index form. And we want that to give us the power of 1, the power of 2, and 3 respectively, so that 39 can be equal to 27 plus 9 plus 3. But 27 can be written as 3 to the power of 3, and 9 can be written as 3 to the power of 2. Also, 3 is same as 3 to the power of 1. Our equation will become x to the power of 1 plus x to the power of 2 plus x to the power of 3 equal to 27 plus 9 plus 3. This same thing as to the power of 1 plus s to the power of 2 plus s to the power of 3 equals to 3 to the power of 3 plus 3 to the power of 2 plus 3 to the power of 1. The next thing we'll do is to group them according to their powers. That is x to the power of 1 minus 3 to the power of 1, crossing this equal sign becomes negative, minus 3 to the power of 1 plus x to the power of 2 minus 3 to the power of 2 plus x to the power of 3 minus 3 to the power of 3, close bracket, all equal to 0. But for here, for x to the power of 2 minus x to the power of 3 is in the form of a to the power of 2 minus b to the power of 2, which is represented as a plus b into a minus b, where a is equal to x and b is 3. So here our equation will become x minus 3 for this, plus for this part we are going to represent with this, which is x plus 3 times x minus 3 plus x to the power of 3 minus 3 to the power of 3, all equal to 0. And again, x to the power of 3 minus 3 to the power of 3 is in the form of a to the power of 3 minus b to the power of 3, which is represented as a minus b times a to the power of 2 plus ab plus b squared, where a is equal to x and b is equal to 3. This means our equation will become x minus 3 for this plus s plus 3 times s minus 3 plus, for this we're going to represent it with this, which is x minus 3 into s squared plus 3s for this plus 3 to the power of 2 all equal to 0. So from here, we are seeing s minus 3, s minus 3, s minus 3 common to the three terms. So we are going to factor it out as s minus 3 into s minus 3 divided by s minus 3 to be 1 plus this whole term divided by s minus 3 to be left with x plus 3 plus this whole term divided by s minus 3 to be left with this part, which is x squared plus 3x plus 9. 3 to the power of 2 is 9, all equal to 0. So if we simplify further, we are going to have x minus 3 into x squared, 3x plus x, which is plus 4x, 9 plus 3, 12 plus 1, 13, plus 13 equal to 0. And here, from the application of zero product rule, we end up having two cases that says either x minus 3 is equal to 0, or here s squared plus 4s plus 13 is equal to 0. And from this part, s obviously is equal to 3. So this is our first value for x. But recall that 2 to the power of m was represented with s, so that 2 to the power of m equal to x. And the first value of s is 3, so that 2 to the power of m will be equal to 3. So we're going to apply log to base 10 on both sides, and it will become log 2 to the power of m is equal to log 3. So if we solve this very one, we're going to have m log 2 to be equal to log 3, since the power will come down to multiply the log. So here, we can divide by log 2 on both sides as the coefficient of m log 2 all over log 2. Here, log 2 divided by log 2 will be giving us 1, which is left with m, which is equal to log 3 over log 2. A more simplified version, m will be equal to log 3 breaks 2. So this is the value of m for the first case. And for the second case, where we have x to the power of 2 plus 4s plus 13 equals to 0, which is x to the power of 2 plus 4s plus 13 is equal to 0. This is case 2. So first, we will check if it will give a real solution by using a discriminant. That is, discriminant formula is given as theta is equals to b squared minus 4ac. Here, b is 4, 4 to the power of 2 minus 4 times a is 1 times c is 13. And if we solve this very one, 4 to the power of 2, this gives us 16 minus 4 times 1 times 13, 52. Theta therefore is equal to 16 minus 52 is minus 36. And this is far less than 0, which means that we solve this very quadratic equation. The values we will have will be complex number, that is, they cannot be found on the number line. So whatever value we have from here will be rejected. So next, we will verify if the value we got from m equals to log 3 to base 2 actually satisfy the original equation. Our original equation is given to be 2 to the power of m plus 4 to the power of m plus 8 to the power of m is equal to 39. So here, 2 to the power of m plus 2 to the power of 2 which is 4 raised to the power of m plus 2 to the power of 3, and that is 8 to the power of m, is equals to 39. So we're going to replace the value of m as 2 to the power of log 3 base 2 plus 2 to the power of 2 log 3 base 2 plus 2 to the power of 3 log 3 base 2. Could this be equal to 39? And this can be equal to 2 to the power of log 3 base 2 plus here 2 to the power of log 3 to the power of 2 base 2. The power goes up plus 2 to the power of log 3 power 3 base 2. Could this be equal to 39? This is also equal to 2 to the power of log 3 base 2 plus 2 to the power of log 3 to the power of 2 is 9 base 2 plus 2 to the power of log 3 to the power of 3, that is 27 base 2. Is it actually equals to 39? So recall that a log b base a is given as b. So a base number with a log of the same base is equal to 1. So here 2 and log to base 2 will be cancelled out, be left with 3, and 2 to log base 2 will be cancelled out, will be left with 9. Also here, what is left is 27. So if you bring this value out, we are going to have 3 plus 9 plus 27. Can this be equals to 39? So here, 3 plus 9 plus 27 is 39. Is definitely equals to 39. This shows that the value of m as m equals to log 3 base 2 actually is true, because it satisfies the original equation. Thank you for staying tuned to the end. Bye bye.